What do we have for x to the fifth? This times that, oh, I get a 1 over 4 factorial, right? What else do I have? Plus 112, all right. That one, yeah, 1 plus 1 over 5 factorial. All right, I think that's enough. Let's just keep the first 3 for this example. Can you clean this up? Well, this is x. What do you got here? Two-thirds, yeah. This is 3 minus 1 sixth. It's 4 sixths. It's minus 2/3. Right? Over here, let me go for something like this is 5 factorial. What do I have upstairs? That would give me a what? A 5 plus, let's see here, 12 is 3 times 4, so 5 factorial is what? 5 times 4 times 3, 2. So basically the 1 over 12 is equal to 5 factorial divided by 12 times 5 factorial, which is what? That's really, these guys are canceling with it. So it gives me 10, right? Is that right? And then plus what? Did I do that right? I don't know. Is 10 over 5 factorial? Let's check it. 10 over 5 factorial, is it 112? Okay. 1 over 5 factorial, well, that's plus 1, right? All right. Huh, interesting. Let's write it like this. 1/2 of 2x minus 1 over 3 factorial times 2x cubed plus 1 over 5 factorial times 2x to the 5th power then. Is that legit? This is like, this is a 6, right? So I have a 6, I've got a 2. This together is a 12. This is giving 8. 8 over 12 is 2/3. I haven't changed it, I just rewrote it. And you can check the same over here. This is 32, and I'm dividing by a 2 times 5 factorial. That's the same as 16 over 5 factorial. What is this? I mean, this is totally unsurprising, right? Because you guys already know sine of x times the cosine of x is equal to 1/2 of the sine of 2x, right? Yeah. I knew what I was looking for. I mean, I created this example to show you a point, which is that we can rediscover. Well, by the way, this. Okay, so another way to look at this is how you could derive. You could derive this trig identity by multiplication of series. I think I prefer the imaginary exponential technique personally. Like this seems like a hard way to derive trigonometric identities, but it is something you could do. I mean, how did I see to put the 2x there? I don't know a good answer to that. It's like, you asked me, how did I know what's behind the curtain? Well, it's because I'm standing behind the curtain. I mean, I don't know what to say about that. It's hard for me to answer that from my perspective. If somebody else in here had said 2x, then you could ask them. Anyone have that thought? Curses. Here, another, oh yes. I didn't divide by 6. Oh. So this is gone. Oh, yeah, I'm sorry. Good. At least they understood. I apparently have lost understanding, but yes. Thank you. Well, folks, trust me when I tell you I would like to stay here and tell you more math, but I unfortunately must go because I have something very exciting to do. Namely, I must go sign my tax papers from this year. So my wife is going to be waiting for me outside if I don't leave and get there.